Hello, Chemistry 11. This is Mr. Chan. And today, what I wanted to do was introduce you to something that is the basic foundation for any chemistry that you do from now on. And it's basically the mole concept. But before we approach the mole concept, what I wanted to do was I wanted to go back to when back in chemistry, even Science 9 or Science 10, remember we focused on, you learned about the atomic mass. So let's say for in this case, nitrogen was 14. So back in grade 9 and back in grade 10, when you folks did this, you learned, oh yes, it's 7 protons and 7 neutrons, and that would give you 14 for nitrogen. But in actuality was, how did they get that number? And so how they got that number was by comparing every single particle with each other. And the way they got this mass is to compare one atom with another. And this comparison is called the relative mass. So let's say, for example, we had hydrogen. Now, hydrogen, you recall, has a mass of 1. Now, if we took nitrogen, we have a mass of 14. Now, why is it a mass of 1 and a mass of 14? How do they get that number? Is because nitrogen is 14 times heavier than hydrogen. So that is why it was given the mass of 14. So if one atom of hydrogen had a mass of 1, nitrogen, one atom of nitrogen was 14 times heavier. This is why you gave it the mass of 14. Now, this actually works for other ones as well. So in this particular case, if we look at oxygen, why was oxygen an atomic mass of 16? Is because one atom of oxygen is 16 times heavier than one atom of hydrogen. Now, in this particular case, the advantage of using this relative mass is that the relative difference stays constant as long as the number of particles remains the same. So what do I mean by this? So let's say we had hydrogen. Okay, so hydrogen versus, let's use nitrogen. Now, if we were to make it into a little table, we know that hydrogen has a mass of 1, while nitrogen has a mass of 14. And giving back from my previous notes up here, the reason why is that it was 14 times heavier. Now, what if we had a pair of hydrogen? So if we had a pair, this would be 2, this would be 28. Okay, now what if we had a dozen? If we had a dozen hydrogens, this would be 12 because 1 times 12. And if we had a dozen nitrogens, what happens is if I take hydrogen 14 times 12, I get a relative mass of 168. Now, notice in this particular case, nitrogen is always 14 times heavier than hydrogen. And so notice here, if we were to do this, we multiply by 14, and here we multiply by 14. All of these we multiplied by 14. And notice that ratio stays constant so long as we have the same number. So if we had a pair of hydrogen, we compare it to a pair of nitrogens. you notice it's always going to be 14 times heavier. If we had a dozen hydrogens and versus a dozen nitrogens, it will always be 14 times heavier. So that's the one advantage of relative mass, is this sort of ratio always remains constant so long as the number of particles remain the same. Now, when we talk about relative mass, the relative mass of an atom is called its atomic mass and has the units of AMU, or atomic mass unit. Now, to convert the atomic mass unit to a unit we can use in everyday life, chemists use a unit called the mole, spelled M-O-L-E, or in some books they just use M-O-L, which represents a specific number. So the mole represents 6.023 times 10 to the 23rd, and this is called Avogadro's number. And this is a measured number. Now, for this unit, along with the idea of relative mass, allows the following relationship to exist in chemistry. So when we have 1 mole of whatever substance, in this case atoms or molecules, we have 6.02 times 10 to the 23, which is equal to the atomic mass or molar mass in grams. So what do I mean by this? So let's say, for example, I have 1 mole of, let's say, carbon. Now, for 1 mole of carbon, what that means is that you have 1 times 6.023 times 10 to 23 carbons, which means you also have 1 times 12.0 grams of carbon. So if I use the word carbon atoms, I have carbon atoms, and I have carbon atoms. So in this particular case, the mole represents 6.02 times 10 to the 23, which is equal to the atomic mass of carbon in grams. So how did I get that number 12? Is if we take a look at the periodic table for carbon, notice the atomic mass is, let's wait for my computer to, here we go. What we have here, if I erase this here, is what I have is I have carbon here as a mass of 12.017. Okay. Now, it doesn't matter if we have atoms or molecules. Let me give you an example here. So let's say I have 1 moles of H2O molecule. Now, M/C for me is molecules. So this is 1 times 6.023 times 10 to 23 H2O molecules. And that is equal to 1 times 18.0 grams of H2O molecules. Now notice 1 mole is equal to 6.02 times 10 to the 23. And notice in this case, it's equal to the mass of 18 grams of H2O. Okay, now how did I get the 18 grams? Is if you take a look at your periodic table, let's wait for my computer to, come on computer. So oxygen has an atomic mass of 16. And for hydrogen, because I have 2 of them, okay, what's going on with my computer? Oopsie, come on computer. Okay, my computer's a little slow here. You notice hydrogen has an atomic mass of 1. And since I have 2 of them, what happens is I multiply by 2, and that is how I get 18. Okay, so that is where I got this number 18 from. Now, notice the relationship is constant regardless of whether one is talking about atoms or molecules. So notice in my example I just gave you, notice I'm talking about 1 mole of carbon, 1 mole of water, 2 different particles, but you notice the number is exactly the same, 6.02 times 10 to the 23, and the only difference is the mass. Now, it says here, when talking about molecules, we deal with molar mass. And so what is molar mass? So when we're talking about molecules, we're dealing with molar mass or molecular mass. And this is done by adding up the atomic masses of all the elements in the formula. Okay? And basically, why do we need to use the mole? Is basically, it's a simple way to convert between units in chemistry. So when you're given the mass, what you could do is to go to moles, you divide by molar mass, okay? And then to go from moles to particles, you multiply by 6.02 times 10 to the 23rd. In this particular case, to go from moles to mass, you multiply by molar mass. To go from particles to moles, you multiply by 6.02 times 10 to the 23rd. Now, why do we need to use the moles? Why do you need to learn this? Is because when you take a look at this, an example would be like here. In this particular picture, I have 12 scissors. And in the bottom of the picture, I have 12 paper clips. Now, scissors have different uses. They have different characteristics. You notice there's plastic on them and stuff like that, while paper clips is just pure metal. So each of them have different characteristics. They have different uses. They have different sizes. They have different masses. But the commonality is that I have 12 scissors and I have 12 paper clips. And so if I wanted to see the direct comparison, I would use that commonality of 12 between the both of them. And that is the whole basis of the units of moles, is so that we can find a common unit between atoms and molecules and so on. Okay, now on the bottom of your sheet, I also gave you another way to calculate moles mass and molar mass by a triangle. And again, for example, if you want to find the molar mass, so what you have here is, let's say you want to find molar mass. So what you do is you take the mass and divide it by the number of moles. Conversely, if you wanted to find the number of moles, you take the mass divided by the molar mass. And if you want to find the mass, just do that here. If I want to find the mass, I just take moles times the molar mass. Okay, so you can use this particular triangle as well. Now, it doesn't matter which method you use, okay, so long as you sort of get the answer. Now, these two little formulas is a great starting point for your journey into the moles. Now, in your textbook on page, I believe, 108, what you will see is you'll have this thing called the heart of moles. Moles is the heart of chemistry. And this is another way for you to sort of figure out how to do the mole calculations. Okay, so if you start with a mass of an element, divide it by the molar mass, you get the number of moles. You take the moles, multiply it by 6.02 times 10 to the 23rd. That gives you the number of molecules. Okay, so you can use this, or you can use this as a starting point in your journey of the moles. Now, how I'm going to approach it is I'm going to do it a little bit differently. Okay, what I'm going to do is, when I give you the examples, I want to use a process that hopefully most of you are familiar with. Now, if we went back to the introduction of SI prefixes and conversion, remember we had this cross multiplication. Okay, this was back in my video, I believe, number 5, where we do the cross multiplication, cancel out of units, and that was how you got your answer. Now, for me, what I want to do is I want to copy this particular process and use it in the mole concept. Okay, so what I'm going to do is I'm going to give you a non-chemistry example right now, and then I want to go through it with you. Okay, so what I'm going to do right now is, okay, so let's say, for example here, given the relationship 1 dozen oranges is equal to 1 times 12 oranges is equal to 1 times 450 grams of oranges, notice I have the relationship. A dozen is 1 times 12, which is 450 grams. So let's say, for example, how many grams would 35 oranges weigh? Now, what I would do is, for me, I would do it this way. So let's say I have A. Okay, so I would go X grams is equal to 35 oranges. Now, so what I would do is I would change it into a fraction. So I go X grams over 35 oranges is equal to 1 times 450 grams, oopsie, yeah, of oranges all over 1 times 12 oranges. Now, where did I get the numbers from? In this case, the 1 times 450 grams of oranges is this one right here. And then the 1 times 12 oranges is the one right here. Okay, now how did I know to put the grams on top and the number of oranges on the bottom? Is based upon what I had set up here in this particular fraction. Now, some of you might say, well, Mr. Chan, could we put oranges on top and grams on the bottom? Yeah. All right, then all you need to do is you need to just flip the other half of the equation. So in this case, what we do is then we cross multiply. So what I have is, hopefully you remember your math. So what I have is 35 oranges. Okay. 35 oranges times, what we have here, 450, 1 times, oopsie, 1 times 450 grams is equal to X grams times 1 times 12. Okay. So I just cross multiplied it. And then what I do is I divide it, both sides, by 1 times 12 oranges. Okay. Oranges, 1 times 12 oranges. So what happens is these units cancel out, the units here. I'm left with grams. So if I do this, this also cancels out. So I get 35 times 450 divided by 12 So I get, okay, this is not working right now. We get 1312.5 grams. Okay. And that's basically very similar to what you had in the previous, where I did the, if we do the new share, okay. Let me go here. Come on. Share. Okay, why is it not working? Oh, there we go. Okay. I guess my computer is not working very well. Okay. All right. Doesn't matter. All right. Okay. So what we have here is we have the cross multiplying. Okay. So you do the cross multiplication to get the units that you want. Okay. Now, so I'm just going to do the second question. If I had 1,200 grams of oranges, how many dozen oranges do you have? Now, notice the wording is a little bit different. Okay. So in this particular case, the setup is almost exactly the same. So for question number B, so if I had X dozen would be equal to 1,200 grams of oranges. So again, let's do it into a fraction like what I did here in the A. So I go X dozen all over 1,200 grams is equal to, in this particular case, I would say 1 dozen all over, how much do I have? 1 times 450 grams. Okay. Again, what you can do is you can cross multiply. So what you have is 1 dozen times 1,200 grams is equal to X dozen times 1 times 450 grams. You divide both sides by 1 times 450 grams. One times 450 grams. And so what you have is the cancellation of here, and you solve for X dozen is equal to 1 times 1,200 divided by 450, and that would give you 2.667 dozen. Okay, now if you take a look at these two examples, notice the process is exactly the same where I'm doing the cross multiplication. You want to focus on, notice what I did here and what I did here. Now, what you want to know is which of the conversions did I use? Notice in this case, I used a different dozen. I used 1 dozen and 1 times 450 grams. In this case up here, notice I used 1 times 450 grams and 1 times 12. It all depends on what I am given in the question. So notice in question number A, I'm asking for the number of grams. and I'm given 35 oranges. In the second question, I'm given grams, and I want how many dozen. Okay, so in this particular case, where the tricky part comes in is, do you know which units to use for the calculations? Now, what I'm going to do is I'm going to go over a couple of examples and explain to you what I mean by reading the question. All right, so in your particular worksheet, what I'm going to do is this the worksheet here? Nope. Here's the worksheet. Now, what I'm going to do is I'm going to go over a couple of questions. So the first one I'm going to go over is question number 2. Oopsie. Question number 2B. Okay. And I'm going to go over question number 3B as well. So question number 2B, or not 2B, get it? Haha. And question number 3B. Now, so reading question number 2B, it says calculate the number of moles in each of the following. So notice I have 49 grams of H2SO4. So I want the number of moles in 49 grams of H2SO4. So if I were to go here, so for question number 2B, I want to calculate X mole in 49 grams of H2SO4. So the first thing I would go is look at my relationship. So here I would go 1 mole of H2SO4 is equal to 1 times 6.023 times 10 to 23 H2SO4. And that would be equal to, if I just expand this a little bit, let's see, sulfur is 32.1 and 16 times 4 and 2. So what I have is 98.1 grams of H2SO4. Now, in this particular case, notice I want moles, so I have moles of H2SO4. And in this case, I'm given 49 grams of H2SO4, so I use this in my conversion. Okay, so then what I would do is I set up the question. So X moles over 49 grams of H2SO4, that would be equal to 1 mole of H2SO4 all over 98.1 grams of H2SO4. Again, what I do is I do cross multiplication. Okay, so I have X moles times 98.1 grams is equal to 1 mole times 49 grams. So I divide both sides by 98.1 grams, divide by 98.1 grams. And then what I do is I cancel it out here. And so my X moles would be equal to 49 divided by 98.1. And so I would get an answer of 0.499 moles of H2SO4. Okay. Now, if I look at my answer for question number 2B, see here, look at my answer. If I scroll down for question number 2B, and notice the answer is 0.50. Now, why is the answer 0.50 while I wrote 0.499? Because of sig figs. 49 has 2 sig figs, so the answer should be 0.50. Okay? Now, notice again, if I take a look at this particular scenario, this cross multiplication, it is exactly the same as what I did up here in the two examples. Okay? And if we were to take a look at my video, oh, I don't have it anymore. Oh, there we go. Share. Notice again, what you have is the cross multiplication. All right, so I'm using the exact same process as what you learned before. Now, let me give you one final example and then we will call it a day. Okay, so I said I was going to do question number, I always print this out. Let's say I do question number 3B. Okay, it says calculate the number of molecules in each of the following. So in this case, notice the word molecules. Okay, now please make sure you know the difference between moles and molecules. Moles is a unit. Molecules is a description of a particle. Okay, make sure you know the difference. They look similar, they sound similar, but they are very different. For example, my name is Mr. Chan, C-H-A-N. We have a math teacher, Mr. Chen, C-H-I-E-N. We sound the same. Our first two letters are exactly the same, but one teaches math and one teaches chemistry. Okay, so please make sure you know the difference. So if I were to do question number 3B, okay, so question number 3B, I'm just going to do a line here. So for question number 3B, I want the X number of molecules. Again, M/C is molecules in, what did I want? I wanted 40 grams of water. So in 40.0 grams of H2O. So again, what's the setup? So 1 mole of H2O, I'm going to say the word molecule, is equal to 1 times 6.023 times 10 to the 23 water molecules. And that is equal to 1 times 18.0 grams of water molecules. Okay, now in this particular case, I'm asking for the actual number. So I'm using this particular variable. And then I have 40 grams of water. Then I use this one here. So in this particular case, if I have X molecules over 40.0 grams of water, that is equal to 1 times 6.023 times 10 to the 23 water molecules, all over 1 times 18.0 grams of water molecules. Again, what we can do is we can cross multiply. And so if I go X molecules times, I'm just going to say 18.0 grams of H2O, that's equal to 40.0 grams times 6.023 times 10 to the 23. Divide both sides by 18. H2O, 18.0 grams H2O. Okay, cancel these out. So X molecules would be 40 divided by 18 times 6.023 e to the 23rd. 6.023 e to the 23rd. So that would give me an answer of 1.34 times 10 to the 24 H2O molecules. Okay, now again, if we take a look at the answer, if we take a look at question number 3b, the answer is 1.34 times 10 to the 24. Okay, now I will be giving some homework questions, but please make sure as you are looking at these, try to take a look at the question. In this case, how many moles? Okay, what is the mass? Okay, and by knowing, and in this case again, what is the mass? So in this particular case, by knowing what they're asking for, it sort of helps you figure out how to start in terms of what units you're going to be using for your cross multiplications. Okay, now, if you take a look at your Heath chemistry textbooks, what they do is they give you a bunch of examples. If you take a look on page number 99, notice what they do is they actually do give you the same idea in terms of using ratios, okay? But in this case, how they do the question is by canceling out the units. Same thing with the bottom of page 100. You take a look, if you go through it, you see how they go through the thought process, and they do it by canceling out the units. Page 101. Again, what they do is they go through it by canceling out units. Okay, and example 4.4 on page 101, they go through it by canceling out units. So, and 102. So my suggestion would be this. If you are starting out and you just want to get to know how to use this concept, I have no problems with you just plugging in the numbers and just memorizing the formula that is found up here. But my suggestion would be start to do unit conversions, like this cross multiplication, where you are looking at ratios, and this will get you a lot further ahead, okay? And it builds on your understanding, okay? So I don't mind you, again, doing your questions if you do this particular sheet, but my recommendation is you should start moving towards doing it this way, where you're doing the crossing out the units and looking at ratios. And even if you are going into your textbook on page 102, do you know what they were doing on page 102? How did they get the numbers? How did they cancel out the units? Like in examples 4-6 as well. All right, folks? All right, thank you very much. Have a great day. Bye-bye.